to take a look at this function and find the four things that we've been finding today. The x-intercepts, the y-intercept, we want to be able to find the vertical asymptote or asymptotes, and also find the horizontal asymptote for this function. Now, as in previous examples, to find the x-intercept, we need to know what the zeros of the numerator are. But I can't find the zeros of the numerator unless I know what those factors are. So let's go ahead and take this and factor it out. I'm going to come over here and say 2x squared minus 15x's plus 28. I need to take the 2 and the 28, multiplies to 56. What factors of 56 add to negative 15? That'd be negative 7 and negative 8. So I'm going to use these two to help me group this. So 2x squared minus 7x's minus 8x, because that needs to be a negative 8, and minus or plus 28. That allows me to group this into two groups. The first group, all I can take out is an x, and I have a 2x minus 7 left over. The second group, I can take a negative, and I can take a, which will allow this to be 2x minus 7 again. So my two factors for the numerator are 2x minus 7 and x minus 4. I'm going to write those in. 2x minus 7 and x minus 4 become the two factors for that numerator. Now, once I have intercepts, because it's just the zeros of those two factors. So x is equal to 7 over 2 and x is equal to positive 4 would become the x-intercepts for this function right here. In order to find the y-intercepts, I'm going to substitute a 0 in for each one of those x's. So if I square a 0 and multiply by 2, I get 0 minus another 0 and then plus 28, all divided by 0 plus 1 multiplied by 0 minus 7. So in the numerator, that would simplify down to a 28. If I simplify each of these, I get a 1 times a negative 7, ends up being a negative 7. Divide those out, I end up getting negative 4 for the y-intercept. Vertical asymptotes. When we have a rational function like this, we want to look at the denominator factors to find the vertical asymptotes. So in this case, my two zeros of the denominator would be negative 1/3 for the first factor, and x is equal to 7 for the second factor. And finally, the horizontal asymptotes. If I look up at this function and were to approximate this, I could say 2x squared plus a bunch of other stuff in the numerator. And then if I were to distribute this denominator out, I'd end up getting a 3x squared plus other terms. And I don't really care about the other terms when I'm looking at the horizontal asymptote. I care about looking at those dominant powers of x, in this case an x squared. If I divide the 2x squared by 3x squared, I end up getting 2/3. Once I have that value, that becomes my horizontal asymptote. Y is equal to 2/3. So when I have a rational function and I want to find the x-intercepts, I need to factor the numerator if it's not already factored, and then find the zeros of that numerator. If I want to find the y-intercept of a rational function or any type of function, I'm going to plug in a 0 for each of those x's and then simplify it down. In this case, we got negative 4. To find the vertical asymptotes, I need to either factor or use the factors of this rational function's denominator. And when I found the zeros, I got a negative 1/3 from the first one, positive 7 from the second one. And then the horizontal asymptote, if I were to multiply out both the numerator and denominator, I look at that term that has the highest exponent. If I divide those out, I end up getting a 2/3. That, y equals 2/3, becomes the horizontal asymptote.